Good afternoon, Professor. We are Group 7, and today we will be sharing our key findings and insights on our group project. Today, we are facing a global health crisis that's directly connected to what we eat. The World Health Organization just reported that over 1 billion people worldwide are now living with obesity, a number that's tripled since the 1970s. This isn't just about weight, it's about skyrocketing rates of heart disease, diabetes, and other serious conditions. The WHO is calling for urgent action from governments and food companies to transform our food supply, specifically to reduce unhealthy fats and sugars while promoting more plant-based proteins and fiber. At the same time, the UN's World Happiness Report shows something fascinating. Countries with better nutrition and food security consistently report higher levels of well-being. It turns out that access to healthy food doesn't just prevent disease, it actually contributes to happiness and life satisfaction. So we're at a critical point where improving nutrition isn't just a health issue. It's essential for building happier, more sustainable societies. That is why understanding exactly what we're eating and how it affects us has never been more important. Do countries with higher average protein or fat intake during winter months tend to report higher happiness? To find out, we combine global food consumption data with the World Happiness Report to analyze seasonal nutrition patterns and their potential correlation with national well-being. Our analysis followed a clear multi-stage methodology. First, we defined winter food intake by joining food data with happiness data for each country. We then calculated the average winter consumption of animal protein, vegetal protein, total protein, and fat. A crucial step was applying hemisphere-specific winter definitions, using December to February for the Northern Hemisphere and June to August for the Southern Hemisphere to ensure accuracy. We prepared the happiness data separately, ensuring score reliability before combining it all into a unified dataset for each country. To measure the relationship, we computed the global averages for protein and fat consumption and happiness scores. These worldwide benchmarks became our central thresholds. We then created a clear classification system, categorizing each country based on whether its winter nutrient intake and happiness score were above or below these global averages. This chart offers a look at how happiness levels relate to protein and fat intake across different countries. It's interesting to see that Brazil scores it high in happiness while maintaining a relatively lower protein intake compared to other countries. Meanwhile, Germany appears to balance a higher protein consumption with a decent happiness score. Japan stands out for having lower fat intake, but still manages to maintain happiness levels. So, what we've learned is that national happiness is complicated. While what a country eats might be related to how happy they are, it's clearly just one part of the story. Things like strong communities, a stable economy, and personal freedom seem to be the real foundation. So, while eating can make you feel better, a happy society is built on much more than just food.
Hi, so for question 17, we are asking a very simple question. Do countries that eat more fat tend to be more happier? The idea is to look at 60 years of fat intake data under the daily intake dataset and compare it with each country's happiness score. Imagine plotting two bar charts per country, one for fat intake and the one for another one for happiness, and seeing whether there's a rise together. This sets a stage for examining whether diet patterns reflect deeper socioeconomic well-beings. Once we calculated the long-term average fat intake from the daily intake dataset and computed the correlation, we found a strong positive relationship, that is a correlation and coefficient of 0.694, showing a strong correlation. The scatter plot confirms it visually also, as it follows on the 45-degree line consistently. Countries with higher fat consumption consistently cluster at higher ends of the happiness scale. This doesn't necessarily mean fat causes happiness, but does show that prosperous countries tend to have both higher fat intake and higher happiness levels.
However, when we look at the top 15 happiest countries, their fat intake in blue varies quite a bit, with countries like Mexico and Costa Rica having significantly lower fat intake compared to the rest, despite a similar happiness score. There are two possible explanations for this. Firstly, happiness is impacted by other metrics such as freedom, economic output, and more. As such, while these countries may have lower average fat intake, their happiness is made up for with higher values in other metrics. Secondly, it could be a case of reverse causality, where instead of greater fat intake resulting in more happiness, it is that higher levels of happiness lead people to consume more fat. However, this seems unlikely as the happiness score is calculated from recent data from 2013 to 2016, whereas the average fat intake was calculated using long-term data, 1961 to 2020. It is unlikely that the relationship is backwards, where happiness results in greater fat consumption, as the fat consumption happened first from 1961. As such, due to the strong correlation, a possible conclusion is that consuming more fat causes greater happiness in countries.
Now, for question 18, I wanted to see whether the country that has more stable calorie intake across the year actually is happier. So, firstly, I took the daily intake data, and for each country, I estimated the average calorie per person for every month in a year. Then I calculated the standard deviation of these 12 values, and that gives us a number that tells us how much calorie intake changes month to month. So a low value means the diet is quite steady, and a high value means it fluctuates. I then match this with the monthly calorie variability with each country's happiness score and plotted them. So the first graph on the left actually combines all the years, and the second graph only focuses on the 2009. So in both charts, red line is almost flat, and the R values are around 0.01, which means that the calorie variability explains about 1% or less the differences of happiness. So based on these data sets, I cannot conclude that countries with lower monthly nutrition variation is not actually clear that they are not happy, and this suggests that the happiness is likely far from the other factors such as income, healthcare, social support, safety, and not just by how stable a calorie intake is over the years.
Now I'll be continuing with question 18. So are countries with lower monthly nutrient variation actually happier? If it is really true that countries with lower monthly nutrient variation are happier, then we should see a very clear pattern. Countries with very stable nutrient intake should mostly sit at the top of the happiness ranking, while countries with very volatile intake should sit near the bottom. So this slide sets the expectation on what we're going to test with our data. So when we calculate the relationship between nutrient variation and happiness, the correlation value turns out to be really small and close to zero. In simple terms, countries with steady nutrients are not consistently happier, while countries with more variable and volatile nutrients are not consistently less happy either. This tells us that monthly nutrient variation on its own does not explain why some countries are happier than others.
Today I'm answering question 19. How do processed diets, fast food menu, health, and national happiness interact? This sounds like three separate things, right? But they are actually quite connected. Across countries, across foods, and across brands like McDonald's and Starbucks, do we see a common pattern? Let me walk through what I discovered. To answer this question properly, I had to connect very different data sets. Firstly, being the daily intake data set, that is, 60 years of processed food intake measured through calories from fat and carbohydrates. Secondly, being the fast food menu health, which are McDonald's and Starbucks specific data coded as a high risk or moderate based fat, sodium, and cholesterol. And third, being the national happiness score, which captures the social economic well being. Together, these data sets let me study not just the food but the bigger lifestyle environment behind it. So how did I actually combine everything? First, I extracted key values, fat intake, daily intake, nutrition stats, menus, and happiness scores. Next, I calculated relationship according to correlations between long-term fat intake, happiness, and dietary risks. Finally, I interpreted the results to have an understanding of what is happening across countries and across food chains. Let's start with the most interesting relationship. Let's move to this understanding of higher fat intake being linked to higher happiness. Here is the first big insight. Does eating more fat make people happier? Not exactly, but the scatter plot tells a story. Countries with high fat intake consistently show higher happiness scores, the correlation of 0.694, which is very strong. Why, would you ask? Because the fat intake is a signal of prosperity. Rich countries can afford more processed food, have better social systems, and therefore report higher happinesses. So this graph is not about biology, it's about economics. Now let's move to McDonald's menu health analysis. Key insights say that gourmet and regular categories show mostly high risk items. Breakfast also contain high fat and high sodium options. And finally, the drinks and condiments look safe but barely matter for total calories. The key question here is, are customers choosing high risk items by accident? Based on the menu structure, the answer is yes. The high risk choices are built in the main categories. Let's understand the calorie distribution now. The blocks plot reinforces the items sit around 400 to 450 kilocalorie. Regular items around 350 to 380 kilocalorie with outliers above 800 calorie. Breakfast and desserts are also stay in 300 to 400 kilocalorie range. Put simply, high calorie defaults are unavoidable in the main McDonald's menu. Now let's try to understand Starbucks menu health and risk profile. When I analyzed the Starbucks, I expected a healthier pattern, but surprisingly, bakery, breakfast, bistro boxes, and sandwiches are 50 to 75% high risk. Only parfait and salads are mostly moderate. So cafe style foods, even though they look healthier, still follow the same process as of McDonald's. Now let's try to understand Starbucks calorie distribution. The block plot confirms that bakery and sandwiches sit around 370 to 410 kilocalories, which are outliers near 500 kilocalories. Hot breakfast and bistro boxes span a wide range. Salads and patties are the only ones true in low calorific options. Again, high calorie items are the default and not an exception here. So now let's look at the bigger picture insights and implications. So what does all of this mean? Across countries, processed foods intake increase with prosperity. Across individuals, happy countries consume more fat and carbohydrates. Across brands, McDonald's and Starbucks both push high fat, high calorie defaults. And across time, these contribute to rising obesity, metabolic diseases and healthcare costs. Processed food exposure is not random, it's structural. To fix this, solutions must also have structural reinformation, healthier defaults, and better public nutritional strategies.
Now, moving on to question 20, does fast food consumption increase health risks? So this table shows McDonald's regular menu after we apply evidence-based cutoff for calories, saturated fat, sodium, and added sugar. Any item that crosses those cutoffs are labeled as high risk and the rest are moderate risk. You can see that many core burgers and mains fall in the high risk group because a single item already delivers a large share of the whole day's recommended intake. So this slide shows the same for Burger King. Using the same benchmark, most of the big burgers and several chicken sandwiches are flagged as high risk on calories, saturated fats, sodium, and sugar. So just like McDonald's, one Burger King main can push someone beyond the daily limits before they even add drinks or fries. Here we look at the Starbucks bakery items where we use the snack specific cutoff, such as 300 calories and 15 grams of total fats to define high risk. So similarly, there are many items that are actually high risk and only some that are moderate risk. And this shows that high risk does not just come from big meals. Coffee shop snacks on their own can already quietly add a lot of calories and fat in a single meal. So this scatter plot combines all the menu items from McDonald's, Burger King, and Starbucks. Each point is one item plotted by calories on the x-axis and total fat on the y-axis. The cloud of points is pushed towards the upper right, meaning many items are high in both calories and fat at the same time. Because our benchmarks are based on daily health guidelines, items in the area are exactly the ones that increase health risk when eaten regularly. To summarize the menu risk, this bar chart shows how many items initiate a high risk compared to moderate risk. The red bar shows the high risk item and the green bar shows the moderate ones. And across all three chains, the high risk bars are huge, which means that a typical customer is more likely to encounter and choose all these high risk menu items. This supports our conclusion that regular fast food consumption is strongly linked to a higher nutritional risk. So can a risk be mitigated? Our data shows that not all menu items are actually equally bad. So our solution to mitigate this is actually just substitute our options for the less health risky ones, like the ones that are moderate risk. So we're not we're simply data scientists, and we're not really here to give you government interventions or other mitigations. So from our point of view, we can just say that instead of completely taking away fast food consumption, just choose the healthier options.
Let's look at question 21. So I'm looking at how the US diet has changed over the long term and what it might mean for their health. So first, we look at the micronutrition chart on the left. So this shows the percentage of calories that the Americans get from carbs, fat, protein from 1961 to 2022. So in the 1960s, just over half of the calories came from carbohydrates. And over time, the red line slowly slows down. And today, carbohydrates are only at about 46% of the calories. So at the same time, the green line for fat actually increased and roughly 35% to about 41%. So the green line, so there's a huge increase. So the blue line is for protein, and the flat is almost flat along the way, about 12 to 13%. And the big shift is not about protein, but the moving from a higher carb diet to a higher fat diet. So on top of that, the total calories per person has went up by 20 to 25% since the 1970s. So Americans are not just eating different calories, they are eating more calories. So let us look at the second chart over here, which also shows the obesity trends. So we can see the impact. In 1990s, the US obesity rate is under 20%, and by 2022, it's above 40%. And other countries such as Australia, Brazil, and the UK are also going up. So the changing balance for more carbs and more fat is not actually solving the health problems, and the obesity still almost tripled. So what is happening here? So one key reason is the ultra processed food. So in the US, more than half of the calories now come from ultra processed food like this. So things like fast food, soft drinks, chips, and ready to eat snacks. So these foods are cheap everywhere, heavily advertised, and quick and convenient, and they are designed to be taste extremely good. So for a lot of people, this fits in their daily lives, having busy schedules, tight budgets, and habits formed since childhood. So since through this, we can see the new healthy trends like plant-based diet, protein shakes, or burning food, but they are still competing against this environment of ultra-processed, high-fat, and high-sugar foods. So a healthier long-term shift would look on focus to a whole grain and the fruits, vegetable, beans, nuts, and healthier oil. So and to cut down on deep fried foods and sugary drinks, and as well as processed snacks. So this kind of diet is actually higher in fiber, more filling, and better for the health and blood sugar.
What month should government increase public awareness of unhealthy food spikes? We tackled a pressing public health question. When and how should government intervene to counter unhealthy eating habits? Our analysis identifies the precise months for targeted campaigns and provides a ready-made menu of healthier food alternatives to promote. Our first step was to identify when unhealthy food consumption peaks. This bar chart reveals a clear pattern. March, April, and February shows the most significant spikes in calorie intake from fats and carbohydrates. This establishes these 3 months as high priority for public health campaigns. A secondary, smaller spike occurs in May and January, making them as medium priority months. For McDonald's, I'm targeting lean, high-protein items. For Starbucks, I'm seeking balanced options with fiber. And for Burger King, given their generally heavier menu, I'm prioritizing protein while setting strict limits on unhealthy fats and sugar. We analyzed menus from major fast food chains to identify genuinely healthier choices. As this table shows, viable options exist. These items are suitable because they are high in protein for satiety, moderate in calories, and low in sugar and unhealthy fats, making them practical and balanced alternatives. So to bring it all together, we now have a clear and actionable path for public health campaign. We know that the most critical time to act is during the early months of the year, particularly from February through April, when consumption of unhealthy foods peaks. We are not just telling people what not to eat. We are giving them a practical and realistic alternative by steering them towards specific, better choices that already exist on popular menus. We can actively promote the lean, high-protein options at McDonald's, the balanced and fiber-rich meals at Starbucks, and the protein-focused items with minimal unhealthy fats at Burger King. By launching focused awareness efforts during these high-risk months and explicitly endorsing these healthier, readily available alternatives, we move beyond vague advice. We give the public a concrete and manageable way to make it a healthier choice, turning a moment of temptation into an opportunity for better health.
The last question asks us to investigate the impact of a reduction of fat or sugar-based diets on happiness, health, and economic outcomes, and also asks if countries should implicitly or explicitly regulate sugar consumption. For the first half, we need to find values for fat and sugar intake and compare them with 3 metrics: happiness, health, and economic outcomes. Then, we need to find the relationship between them with correlation and plots. And lastly, we need to analyze and explain our findings. We can find the data required in the happiness dataset and the daily intake dataset. The happiness dataset has all 3 metrics, but the data was scored based on samples collected from 2013 to 2016. So, for our fat and sugar intake, we should use those years as a range as well. Under daily intake data, we have fat intake but no data on sugar. So we decided to see if we could use carbohydrate data as a substitute. Using Burger King menu items, we found the correlation between sugar and carb in meal items. As we can see, there is a strong correlation, meaning that they share a similar trend in food and drink items, making it a suitable proxy for sugar. We then found the correlation of fat and carb intake with the 3 metrics. The figure and correlation values show that there is a strong correlation between fat intake and the 3 metrics, meaning that reducing fat intake could decrease all 3 metrics. Or the relationship could be backwards, where having higher of the 3 metrics leads people to consume more fat. If that's the case, reducing fat intake would not do anything to the 3 metrics. For carbs or sugar, there is a weak correlation. This means that reducing sugar intake would result in no meaningful changes. But that doesn't make a lot of sense, right? Because if we consume too much sugar, we can get health conditions like obesity and type 2 diabetes. So at the very least, there should be a negative correlation with health. But why is there not one? It may be because we did not actually use real sugar intake data, thus causing measurement errors. In any case, even if we had an accurate correlation and trend, we cannot tell which way the relationship goes and which is causing what, meaning that we cannot know if a reduction in fat and sugar-based diets would impact the 3 metrics at all, or if it's the 3 metrics changing that is impacting the diets. As such, a key insight we have taken away from this is that trend analysis alone is not enough for a comprehensive evaluation of the relationship. We need other analytical information like clinical evidence to back up and explain our trends to fully understand what the numbers mean. For the next half, the question asks if countries should explicitly or implicitly regulate sugar consumption. Explicit regulation would mean that people have less freedom to choose their diet. But how important is freedom relative to overall happiness? We plotted a proportion bar graph where blue is the freedom's contribution to the happiness score. As we can see, freedom is only a tiny proportion of overall happiness, meaning that explicit regulation will not decrease that happiness that much for most countries. But it will still affect it, so we should not use explicit regulation recklessly. Ideally, we recommend that countries use a combination of both explicit regulation, like Mexico's 10% sugar tax, and implicit regulation, like Singapore's Nutri-Grade. To find a balance between these two, we need to know how much the country values freedom and what their health situation is. If freedom is more important to the country, less explicit regulation should be used. If the health of the country is poorer, more explicit regulation should be used to improve the health of the citizens quicker. That is all for our presentation. Thank you.